Hello, my name is Mike Smoyer, President at Digital Government Institute. Thank you for joining us. Our topic today is the data lake approach to cross-systems records management. Agency data can live in a variety of places and storage types, and at times the volume and details of the content can be a mystery. Our goal today is to share how funneling all agency content into a data lake, connecting content sources including email, file shares, physical records, and more. The data lake approach can ensure legal and regulatory records compliance across systems and leverage search and discovery capabilities without affecting end users. Before we get started, at any time during this presentation, if you'd like to submit a question, click on the General Chat tab on the lower left-hand side of your screen. We will address questions after the presentation. If you have any technical difficulties, follow the same procedure as submitting a question. And then third, a copy of the presentation is available for download on the lower right-hand side of your screen. Look for the file icon. It's now my pleasure to introduce our speaker. With us today is Graham Sibley. He's founder and CEO of Collabware. He has successfully implemented dozens of enterprise content management solutions over almost 20 years of experience and created the first rules-based record-keeping product for Microsoft SharePoint. Thank you for joining us today. Graham?
Thanks, Mike. Appreciate being here, and thanks everyone for joining us as well. So as Mike said, we're going to talk about the data lake approach to cross-system records management. But it's often a term that people don't recognize right off the bat, especially when we're trying to combine the concept of data lake and records management. So to really begin, I want to start by setting the scene as to why we even want to talk about this. Why does it actually mean something? And the reason why it means something is because we now live in an artificial intelligence economy. Everything that we're doing in terms of business activities, technology investments, even the latest apps and gadgets and games that are coming out on the market are all driven by this idea of harnessing machines for artificial intelligence. Now, that's not to say that we're there entirely right now, but in order to really talk about what we're going to do with records management, we have to think about the place we're at currently and where we're going, and artificial intelligence is a key part of that equation. If we think about the time that we've kind of elapsed from the 80s, where we really were heavily paper-based, we moved into the 90s and we started to deal with electronic content. We were dealing with the beginnings of our internet systems. We moved into the 2000s and it was all about collaboration. It was all about let's work together on content, let's create documents together, and we see the beginnings of Microsoft SharePoint starts to appear in that time frame. And then the 2010s, we really focused on the idea of automation. So now we want to take this information and we want to automate business processes. So we got like robotic process automation, we got scan and capture processing, we've got all sorts of workflow activities. And it's built up to today where it's not just about automating anymore. It's about gaining new insights and intelligence from the information that's being created. From the information that's being executed in business processes, we want to harness that and improve our organizations and, in many cases, improve the services we're able to add to our customers. There's some real key driving points here. Now, one of those key driving points is on the idea of unstructured content growth. We've all experienced it. We know how much it's growing. We've got all sorts of avenues for content creation now. It's not just Word documents and Excels. It's PDFs, it's instant messages, it's emails. We've got all this stuff growing and growing and growing. And that volume of content is becoming a problem. It's a problem that's not easily solved by humans, and this is where we want to start thinking about how do we leverage artificial intelligence. We're also looking at some new problems that come with having all this information, right? We have the concept of risk profile for information portfolios. And one of those risk profile items is situations like ransomware, where we have a large portfolio of information that may be unprotected or inadequately protected. And we need to think about what are we going to do with that information to secure it and protect it so that we can harness it properly for any sort of information intelligence and insights. We also have the legal and regulatory requirements that most organizations need to meet. Certainly, departments and agencies have their legal requirements that they need to meet. And these legislative requirements are a key driver for the concept of what we need to do. Often it doesn't tell us how we need to do it, or if it does tell us how to do it, it's telling us in a way that was written for paper 20, 30 years ago. When we don't approach this with new insights and new intelligence, we end up in situations where information goes unmanaged. And when it goes unmanaged, we end up with audit failures, we end up with fines, and often we can end up with legal ramifications, or in some cases, public relations ramifications, where that lack of management of our information causes significant issues for our organizations. And when we look at productivity, we have to examine having that volume of information and being required to execute a Freedom of Information request becomes a significant challenge. Here we're looking at the spend in 2015 being $450 million across the US federal government. Now that number is much bigger now because the information has grown significantly. And we have two possible outcomes that take place. One, we spend the time searching and it takes a lot of time and a lot of effort, and we're searching a whole bunch of different systems and manual solutions and all sorts of activities, and it's just a huge productivity sink. And then our outcomes are either A, we didn't find anything, which I believe I saw a stat recently said, upwards of 60% of FOIA requests actually don't result in any information, which I find hard to believe. I believe that it is probably 60%. I find it hard to believe we don't have the information. Or option two is we end up producing information that is only a part of what we were supposed to find. And then only afterwards do we find the other part, and we end up in a situation where now we may have provided the wrong or outdated information and start to make decisions on that information, only to find out the search wasn't quite adequate and we didn't retrieve everything we needed. So hence our decision making or our actions are now based on outdated information. So this is a really significant issue that we need to address, because as our volumes grow, it becomes more and more difficult to get our heads around how do we find what we're looking for. And the final step in this equation is that we have to look at how we're going to harness this information. So it's great that we can do a FOIA request and we can find what's needed for an external request, but what about our own internal activities? How do we benefit from the information we've created? How do we leverage that information to gain new insights and transform the way we offer service to our customers, or the way we go about increasing our own productivity or better decision making? And that's really where we start to look at the future and say, well, there's a lot of potential in having this portfolio of information, provided it's properly protected and we have good efficiency on going through it and looking for what we need. Then another stage of this evolution, this intelligence, comes from being able to analyze all that information and derive new meaning and new value. So there is a common theme across all of these activities. And that common theme is that we need to apply artificial intelligence in order to manage this volume of content and enable the transformation we're looking for. Without that artificial intelligence, the volume is too big for humans to adequately understand and process. So we're going to end up in situations where our risk profile gets bigger and bigger, our productivity goes lower and lower, and we're losing out on the valuable information that exists, the valuable information and knowledge that exists in that portfolio of content that we control, manage, and create. So this is really the focal point of what drives our future in terms of information management. But there is a first step. In order to get to the point where you can even begin that journey, you need to look at streaming your information across all your systems into a unified data lake. That's what we're going to talk about today. It's the beginning step in a journey, but it's a foundational step that's required in order to gain the kind of insights that we're looking for. And today we're going to walk through some of the activities we can consider along that journey and things we need to consider as part of our decision making. And we'll take a look at a quick demonstration of some of the benefits we can get. So let's start with, what is a data lake? Because that's going to be the first question you're all thinking, is if you haven't heard the term or looked it up before, which I'm going to guess most of you haven't, what is a data lake? Well, we know a lake is a large body of water, so what's a data lake? Well, it's really, when you think about it, it's like if you stream all your content into a single source, and that single source is basically providing you with some form of data repository where you structure your content in a way that can be analyzed and processed on large volumes. And we pull all that content together in one pool. And that pool is something that we can dip into, and we can dip our toe in and we can get a little bit of insight, or we can start to undertake some heavy duty processing around things like records management. We can do search and discovery. We can execute workflows across all that content, all in this repository. We can do advanced processing. We can do metadata extraction, entity extraction, a range of other activities. And we can perform in-depth analysis over how the content is being utilized, who's utilizing it, when are they utilizing it, and most importantly, we provide a foundation for how we actually archive that content so that we can not only take action now, but we can leverage the innovations in technology and continue to take action for the future. And this is where we really look at the concept of sourcing information from cloud repositories, from on-premises repositories, and leveraging this data lake as our central point of protection, management, analysis, and processing. Now, there's a range of different activities that we can actually leverage and harness from within the data lake. So a couple of things that we're going to take a look at is the centralized snapshot. So when we think about information in terms of all these transactional systems where it lives, so we've got file shares, we might have some SharePoint, maybe we got some line of business systems that are all producing information. They all have different requirements and a different kind of heartbeat that they go through in terms of information evolution. And what the data lake provides us as we stream that content in is a centralized snapshot that we can refer to and process as needed. Now, one of the things that's really powerful about that concept is that as it streams into the data lake, we can enact protection on it. One of the very first things you would consider in a situation like this is what we call worm compliant storage. So it's write once, read many. In order to mitigate our risk profile from any sort of unintentional updates or malicious attacks on our content, we want to ensure that in the data lake, it streams in and it's in an immutable form. It cannot be modified. So we know that we always have the single source of truth in the data lake. So that's what allows us to provide this concept of built-in protection. So we stream it into the data lake from these external sources, and in the data lake, it is immutable and it is automatically protected. Now, in a situation of, let's say, a ransomware attack. Now, the way a ransomware attack is going to work is it's going to attack a portfolio of your content. I'll use a file share as an example. So it's going to attack the content on the file share, and it's going to encrypt it with a key that you don't have. And then they're going to ransom you, and they're going to say, we're only going to give you the unencrypted or unencrypted content for you if you pay us. So that puts you in a pretty big situation of difficulty, because now for this period of time, you do not have access to your content. Now, what you're going to typically do, ideally not pay. Please do not pay. We don't want this to happen more and more. But what you're going to do is you're going to go to your IT team and you're going to say, we need to restore that content. And they're going to attempt to restore, but the problem is that malware is still sitting there. It's going to encrypt it again. So you have to get rid of the malware before you can actually restore. So now you have a time delay in that. Now during this period, again, no one has access to their content. And eventually you're going to get through the process, and it's going to be very time consuming and arduous, and eventually you're going to get through the process of getting rid of the malware and then recovering your backup. But that can take, as has happened for some organizations, that can take weeks or months to get through that process. So one immediate benefit the data lake offers is the idea that we can stream that snapshot content in and have it protected in the data lake in an immutable form. If the ransomware were to attack the file share the data lake is connected to, that would produce a new version in the data lake, but the old version is still there because it is immutable. Now this gives us the protection we need. So while that file share is being recovered and the malware is being removed, you still have access to your content in the data lake. All the processing and activity still takes place. So this is a foundational element of benefit that we get from the data lake. Now, you might say, like, why would the focus be on that? And I can tell you the focus is on that because if, again, we look at the artificial intelligence journey, that only works if we have content that we can process. So we have to protect that content. So that's step one. Step two is now we want to be able to process and utilize that content. The benefit of the data lake approach is it harnesses technology designed for large-scale compute. The systems that you are connecting to source that information, stream that information into the data lake, are typically not designed for large-scale compute. I'll use Office 365 as an example. It's a very commonly deployed platform, very well used, lots of content in it. But if you attempt to go and point an external compute system at that, Microsoft will enact throttling on you. You will not be able to process it at a high rate of speed. And this is for their own protection. This is to prevent any sort of denial of service attacks bringing down Office 365. So we want them to have that protection. But it also then is counter to what we need to achieve, which is we need mass volume compute across that content. So the data lake approach gives us that intermediary focal point where we can stream the content into the data lake and have that data lake designed for mass compute and analysis so that we are not affecting those systems where we're streaming the data from. Instead, we're doing all of our compute right here in the data lake. Some of the things we can do right off the bat: optical character recognition for all images and scanned documents. So basically anyone who was dealing with scanned documents in the mid-90s or earlier will generally not have OCR documents. Those will be TIFF images or PDF images that are not searchable. And so what we want to do is we want to do optical character recognition. We want to extract that and make it all discoverable so we can do our FOIA requests across all that content and actually look into those documents, which are currently probably not part of your FOIA request portfolio. We also want to do audio and video transcription. So we want to make sure that we're actually making all that content discoverable, because again, whether it's a recording or a recording of a webinar such as this, all of that we want to make sure is discoverable as well, because it has the valuable content we want to compute and analyze. Then we can start to get into some really advanced stuff where we can start identifying where our duplicates or similar documents exist and start building relationships between them. We can start doing sensitive data detection, whether it be PII, financial information, or classified information. We can start looking for things and even enacting automated redaction processes on that content within the data lake, because we can compute not just at scale, but unlike existing technology, which will typically look at one document and analyze the text in that one document, with the data lake, we can analyze that text in relation to everything else, unlocking our machine learning and continuing on that journey to artificial intelligence. Some of the really powerful stuff right off the bat is we can do entity extraction, so we can identify all the people, places, things, times, dollar amounts that exist in all of our content and build relationships between them. So now if I need to do a FOIA request on a particular project or person or maybe a vendor, I can actually go and just quickly see all the stuff that is related to that one entity, because the machine learning can identify the entity and the content and link all the items together through relationships. And when it comes to records in particular, we can do auto categorization. We don't want users manually picking categories from file plans. It doesn't work. It's been proven over and over and over again that it doesn't work. We want to harness the machine learning capabilities of a data lake to be able to correctly and very, very quickly auto-categorize content as it's streamed into the lake. That way we know what it is and we know what retention we should be applying to it, and we don't ask the user to do it for us. Now this is really the foundation of what we want to drive from a records management perspective in this data lake. We need to see everything so that we can do our proper management of it and categorize it. We need to be able to do discovery across all that information, and we need to start harnessing the capabilities of machine learning to give us these new insights around sensitive data management, duplicates, entities, metadata tagging, all that stuff that we need to further drive our knowledge discovery in our portfolios of content. Now there's two terms that often come out in records management. There's the concept of the in-place records management, and there's the concept of the centralized records management. I'm sure you've both experienced, or you've experienced both types of solutions. So in place says leave all the content where it is and manage it where it is. It has a lot of pros to it. Centralized says bring all the content to me from those systems and I'll manage it here. Now the centralized doesn't say leave it there, it says take it out of there and bring it to me. So there's pros to that as well. If we look at the pros and cons of both, what we're going to find is that the right solution for the right place and you can make it work. But the beauty of the data lake approach is it sits right in the middle. It is both simultaneously in place and centralized. You get the benefit of in place because you're streaming into the data lake, but you're leaving the original working copy in the system that it's working with. Consider that the non-authoritative record. That's the one the users work with, the business processes work with. We're not going to interfere. We're not going to ask them to do anything. We're going to stream into the data lake, and the authoritative copy or version will live there. That's the one we're going to manage to because we do all our processing on it, and we can categorize it, and we can figure out what it is, and then we can reach back out to that system and say, hey, it's time to get rid of that thing if it still exists. We also get the benefit of the centralized approach in that we see everything from one pane of glass. And we see it not just in sense of, I see it across these in-place systems, but I can compute it. I can do analysis on it all at the same time. And one of the benefits that we get here is that we, by ingesting and streaming into that centralized concept, even though we have the in-place marker out there, by ingesting it, we get protection from technology change itself. So the data lake will allow us to do a certain type of processing today, and as technology evolves, we can do another type of processing on the same content tomorrow. And then we can do it again the next day and constantly evolve that to get more and more value. I like to use the example of the concept of paper. So when we scan a piece of paper and we use optical character recognition with our scanner, we get the quality of that OCR at that time. And then it's electronic, and then it's done. It's OCR. That's the best you're going to get because it can't be reprocessed because you don't really keep the image. You just have the OCR version now. So you've got your in-place concept, which is the paper, and you got your centralized, which is the electronic file. Now, individually, they're both kind of useless because now the in-place copy, the paper, is not something we want to maintain. We want to move away from that. But yet it is the real source of truth. Then we've got the electronic version, which is a version of what was scanned and then stored in our system, which is using the technology that it had available at that time, and it will never get any better. With the data lake approach, we take that barrier away. We could rescan over and over and over again because the very first scan puts in a high format image, and then we can do the OCR over and over and over again. As the OCR engine gets better and better and better and more accurate, we can reprocess that image over and over and over again. So we never lose the value in it. So that's one of the benefits of this kind of duality that we have between the in-place and the centralized records management. So our data lake is going to stream content to connected systems, from connected systems into the data lake. The key point here is that we're not going to impact the user operation of those systems. We're not going to impact the user. We're not going to impact the business process that is executing. It will be completely transparent because the data lake is not meant to replace those systems. It's meant to provide you that centralized pool for management, insights, and extraction. The data lake will protect our content. It will allow us to enact retention in a much more intelligent way because we will be able to leverage artificial intelligence or machine learning compute to properly categorize, to properly apply retention rules, and to ultimately help us unlock new insights and intelligence from that content. So being able to identify sensitive data, being able to identify those relationships between entities. We're going to be able to protect ourselves from those system outages. So not just ransomware, but we can actually look at things like Office 365 as an example goes down for a day. It happens occasionally. It's not often, but it does happen. During that period, the data lake has the copy of the content that you actually want to work with. You can go in, you can search for it, you can recover it. It's there, it's immutable. It can't be overwritten, so you always have your data at your fingertips. We also protect from the idea of accidental deletion, which happens, it happens a lot actually. And what happens in those situations is it usually ends up escalating to IT to try and recover a point in time snapshot of some backup, some point in the past, and it's really not an effective solution. Again, the data lake, because it is both simultaneously in place and centralized, has that authoritative version that you can refer to. If you accidentally deleted it in the in-place system, say from Exchange or from SharePoint, and it went through the recycle bin and it's now gone in those areas, it still exists in the data lake because it is protected and it will not be removed until the retention rules say to remove. immediate benefit we get is the ability to do that advanced search and discovery across all our content, across all versions, across all history, so that our FOIA requests are not only faster, they're much more accurate and leave less chance of risk of some inadvertent mishap in terms of what data was presented. We see everything and we can analyze everything and we can pull it back in a nice little package that we can distribute as needed. Ultimately, the data lake's purpose is to provide us management and insight. But the secondary purpose is to deal with the problem that exists in records management where we put a lot of burden on the users. We ask the users to file information in a particular place with specific metadata and put a particular category on it. And the reality is they just don't do it. And the reason why most records management implementations fail is because they have that core tenet that they are going to provide some structure to the users and the users are going to adhere to that structure. And they don't. Very few of them will. There will be some, but a vast majority will simply say, I have too many other pressing things I need to do. This is not my core responsibility. I'm going to put the data in SharePoint. I'm going to forget the metadata, and it's there, so don't worry about it. Because they don't necessarily understand the ramifications of not managing that information. And we don't need to teach them. Honestly, we should be leveraging technology for these kind of things. This is where it gives us the greatest benefit, is when the machine can replicate basic decision-making over what a piece of content is, categorize it appropriately, apply the retention to it, and don't ask the user to do it. This is where we really want to get to, and that's what the data lake can offer. Now, as I've mentioned, the data lake is not just now. It's part of that journey. It evolves. It increases its capabilities. And because we are harnessing the data lake and we have that immutable content all pooled up in that lake, we can harness the benefits of technology changing and giving us greater degree of processing power, more accuracy, more detailed insights, and we don't have to move the content, migrate the content, or do anything. It's in the data lake, and the data lake is designed for compute, and it will evolve so that the compute becomes more intelligent over time. And that's our journey to artificial intelligence. Is start with the lake, get the content to the lake, and we can begin the journey from here. So now what I want to do is I want to give you a view of our product Collabspace. And Collabspace is the data lake approach to cross-system records management. Collabspace allows us to connect multiple systems, apply all these concepts I have just talked about, and allows us to unlock some insights and some new capabilities. So I'm going to demonstrate a few of those things for us today, and then we'll jump into questions and answers. So I've now switched my screen to my browser, which is connected to Collabspace. And Collabspace is a multi-tenant SaaS solution that is available in the Azure GCC High Government Cloud. And this product allows us to connect multiple sources, stream that content into the data lake with all the protection elements that we need, worm compliance, immutability, version, tracking, auditing, and then allows us to do auto categorization, advanced discovery, OCR, audio video transcription. So we unlock all the potential of the data lake. Now, getting up and running super fast, I'm going to highlight just a couple key points. One, as an administrator, I can come in and I can connect to my content sources. So some I have connected here is Exchange. So if we want to manage our email, we want to manage to the Capstone approach, that's immediately available. You just simply connect up the key Capstone mailboxes and you're done. That's it. You are now managing those mailboxes. You can even get more fine-grained and reach out broader than just Capstone approach. You can actually manage any mailboxes or any sets of mailboxes. You can manage your SharePoint Online, your OneDrive for Business, your Teams SharePoint libraries, and you can manage things like file shares on premises so that you're actually in a situation where maybe there's content that cannot be migrated or you're just not ready to make that migration. You still can manage that content that's sitting on those file shares and apply all these wonderful data lake capabilities to that content. Now, where I'd like to start is once you connect up a data lake, The key component is to stream information into the data lake, and you want all the information, bring all the information into the data lake. So the more you have, the more you can do with it. So number one, we're going to protect it all. That's key. But number two is we want to make it all discoverable. So I'd like to start with just a demonstration of what that really means. Now, we're all used to going and doing searches, so I'm going to do a search. I'm doing an employee search, so I need to find some stuff on my Marcus Brewer employee. Now, if I were doing a file share search, I'm going to see stuff on file share. If I'm doing a SharePoint search, I'm going to see stuff in SharePoint. If I'm doing an Outlook search, I'm going to see stuff in Exchange. In a data lake search, I'm going to see content from everywhere. So here I can see I've got content coming from file shares. I've got content coming from SharePoint. And as I scroll down, we're going to see more file shares, more SharePoint, different locations in SharePoint. I can see a little further here, I can see a mailbox is returning some content. I can see another mailbox, got some OneDrive locations. I've got a whole bunch of stuff returning from all around, all referencing Marcus Brewer. But where it gets really interesting is what content exists to bring me this. So for example, I'm going to take a look at, I'm going to look for my Marcus Brewer employment offer. See this PDF, we're going to start with this. So I'm looking for the employment offer, and I'm going to go ahead and do a preview of this just to make sure it's the right thing I'm looking for. And as I do this preview, it's going to load up and show me that the PDF and the metadata that exists for this PDF. So we'll see a few things going on. Number one, I got a preview of a PDF, and I can zoom and print and all that wonderful stuff. But notice it's actually not text searchable. This is an actual scanned PDF without OCR. Yet it was discovered, not just because of the metadata, but because of the automatic OCR that's taking place. Every image, every scanned document, PDF or TIFF, is automatically put through an OCR process to determine if there's any text in it. And if there is, that text becomes discoverable. That text can then be used to categorize the content or enact workflow processes or whatever wonderful insights we might want to gather. We can see that this content's also been categorized for me, my employee files category, which we'll get to in a moment. Now you might say, well, it's just a search. How is that important or powerful? What I would like to do is I'm going to go to SharePoint, and we're going to take a look at the experience that a normal enterprise deployment would have. Now, in SharePoint, we've all probably used SharePoint or something similar. The concept of organizing all of our information in locations, probably leveraging some folder structure and some metadata here and there, can sprawl out pretty quickly. So in our case, what I want to do is I want to actually go to my human resources location, and I want to look at my employee files here. So we can see I've got those, and I got my Marcus Brewer employee file. Now, there's not a lot of information here. I know precisely what I'm looking for. Most users won't. They'll have to search a much larger set of information, and they won't necessarily know where it lives. As an example, I've got this document here, a Family and Medical Leave Act document. So here we can see it mentions Family and Medical Leave Act, blah, blah, blah. So as a typical user in this kind of environment, I might start with search and say, I'm looking for Family and Medical Leave Act, right? Find me the content that mentions that. It could be a text search for a FOI request. It could be just a regular user doing search, and this is the result they would see, because that is a scanned document, not OCR'd. It's a scanned image document. Those are not discoverable. I'm going to take the exact same query that we just did, and I'm going to do it in the data lake. And in the data lake, because it does all that processing and compute and automatically OCRs everything for us, it's going to search every piece of content available for this text, and it's going to find it. And there it is. And in fact, we can see by its location, it is the exact same content sitting in that SharePoint location that was undiscoverable by SharePoint is discoverable here. It's even doing hit highlighting, showing us where the name is coming from. And when we open up the PDF view, we can see that this is, in fact, where it's getting that information. Now, it's getting this information for Marcus, but This is search and discovery. So I found something. I can find all sorts of stuff. I can actually do all sorts of querying on metadata capabilities. So for example, I may want to go and add some specific metadata fields that I'm really interested in, such as the employee's name, maybe a business unit. I may want to reorder the way this display works. So I'm going to move that up. And I'm going to go ahead and do this. And now I can see I've got another column. And I could go ahead and select these items, do exports. You refine your search, you find what you're looking for, and then you can export just the metadata, or you can export the items if you need to distribute them to perhaps legal for review or something of that nature. So now, because of the data lake, I was able to view or something of that nature. So now, because of the data lake, I was able to ingest and stream that content in, protect it, and get benefit of automatic OCR, which I can tell you the OCR that we're seeing right now is actually generation 3. So it's gone through 3 generations of evolution, where the first generation was good, second was better, third was even better. And the content didn't have to move or get migrated to another solution or get reanalyzed externally. It simply got reprocessed in the data lake as the new technology evolved and all of the extraction got updated. So these are the kind of benefits that we can get. Now, in terms of the functionality itself, we want to talk also about managing this information. So as it comes into the data lake, we protect it, we do OCR, we make it discoverable, we do audio, video, transcription, all those wonderful things. But we do need to manage to our records requirements as well. So any sort of data lake that doesn't do any sort of retention management is kind of open to a really big problem, because that content should not be kept any longer than is necessary. You want to get the value out of it while it is being managed, but once that retention period is met, you either need to session that content up to NARA, or you need to destroy it, or maybe a little bit of both. So those rules need to be encapsulated in any data lake solution that you consider, because without that, that content is going to be sitting there indefinitely, or until someone manually goes through and enacts some sort of deletion on it. In the case of what we're talking about here, everything that comes into the data lake is protected by default, which means it is immutable, it cannot be modified, it cannot be deleted until the retention rules say it's okay to delete. And we manage all of that within the product itself as well. So here we can see I've got my retention schedule, and you can have multiple retention schedules. So you could have the GRS, the general record schedule, and you could have your departmental or agency or component level schedule side by side, so that you're managing them separate with different permissions and being able to enact the changes at different levels as they come in. And we can see within here, I've got my human resources, the employee files, and I can see I've got a policy in effect. And the policies really are matching content to rules, saying if the content is of this type, or has this content, or has these metadata values, or whatever combinations of things that we're looking for, then go ahead and apply a policy and have that policy enact a workflow. And that workflow should provide all of the retention and disposition structure that we need to meet our legislative requirements. And that's ultimately the point of the policy, is to find content that matches, that needs to be managed for retention, apply that retention to it, and enforce that retention on the content. During its life, we can get lots of benefit from it, from FOIA request processing, from all sorts of other activities and business processes we can drive through entity extraction and general search and tagging and all these things. But when the retention is up, it is time to get rid of that content. And in this case, we've got this employee file retention workflow that is going to go ahead and do that for us. Workflows in this particular system are visually designed. They're designed to provide event-based triggering, time-based triggering, and all of it can be managed in the interface. Now, what makes this important and powerful to note is that when it comes to any sort of data lake structure, typically your data lake, if it's done internally, is going to be owned by your IT group. They're not necessarily going to understand retention and disposition. So you want to make sure that you have the capability, as someone who takes that concern, that you have the ability to enforce that on the content without it turning into a ginormous custom development activity that takes many years and many millions of dollars. So in this type of solution, we have a visual workflow designer where you can go in and construct the retention structure you want, pull in the events you want to be able to react to, execute disposition reviews and destructions, and automatically enforce this on the data lake without an IT involvement. You don't want to get to the point where every little retention action requires a whole new project. So in this world, we actually can manage all this centrally because it is a core tenet of the data lake is not just all the benefit we get, but that we can actually do all of our retention and disposition management on this content. So you can imagine, again, we're streaming content in from all sorts of areas. We're pulling it into this data lake where we can do all of our advanced analysis and processing, and we can manage the retention and disposition requirements, legislative requirements, and NAR requirements that we need to meet. We can manage it across all that content, and when it comes time to destroy content, we destroy it from the lake, and we destroy it in the source system if it still exists there. Perhaps it doesn't anymore. Perhaps its usefulness as active content is no longer there, and it was destroyed earlier. But in the lake, it is here as long as it needs to be. And that is a very important thing when we're talking about records management. So there's a wide range of capabilities around physical records and all sorts of electronic records management type things we can do around vital records processing and all these wonderful things. I encourage you to certainly look at those kind of capabilities when you're looking at investing in any form of data lake approach to cross-system records management. Key points to keep in mind is definitely you want to pull all that content into a protected data lake. Make sure your data lake is protected and that you have that retention and records management capability layered on top so you're not causing yourself more pain. In fact, you're solving two problems and more at one time. So with that, we're going to pop back to a Q&A period. So Mike, I'm going to pass it back to you.
Thank you, Graham. Two quick things before we tackle some of these questions that were submitted. One, there's still time to submit a question. If we can't get to it or if we don't have enough time, someone will follow up with you as soon as schedules allow. And two, we will be emailing an archive of the webinar so you can view it again or share it with a colleague. Okay, I have a few questions here, Graham. The first one, what is the main benefit of the data lake approach versus the current processes used by government agencies?
Great question. So let's talk about the current processes so that we know kind of like what our context is. So, you know, we have two main processes, which is number one, yep, records management, big problem. I'll deal with it later. So that's approach number one. Approach number two is, okay, we bought some software and the software is supposed to manage all the records for us. And then we find out that in fact, we now require the users to do a lot of activities. So the software, while it may do great records management, isn't going to help us much because the users aren't actually actively using it. So that's really the situation that exists right now. So how will this help is one, if we imagine the situation of a high-level administration official who has a lot on their plate, they got a lot of activities that they're managing on a day-to-day basis, the last thing you want to be known for is the person who made their workload harder. So what we want to do is we want to make sure that we're connecting up to the systems they're using for their daily activities because that information is important. It does need to be managed, but we don't want to do it in a way that burdens them. So we want to make sure that we're actually providing a solution that will connect and automatically take care of that categorization, that filing, and that management so that we're not increasing their workload. With that, we hit two key requirements. One, the users are going to be happy because they're not being asked to do more work. And that's key. If you want to be successful, do not anger your users. Number two is we're actually enacting protection from the moment an item is created, sent, received. We've got it connected up. It's real time. It comes into the data lake, and we've got it protected. And now the problem of managing falls to us in a world that we control. And that's the best possible solution. So that's how it benefits. The secondary benefit is what we do with it. So we manage it, but now we get all these tangible benefits I talked about around increased FOIA request processing. One example that got relayed to me just last week was an agency where they received a FOIA request, and then so it comes in an email, and then that person who receives it goes and sends it out to a whole bunch of more people, and those people go looking for all the files and all the systems that they need in order to compile it and send it back for the FOIA request. So that could go out to 50 people, it could go out to 200 or 300 people. And they're all going to spend a number of hours looking for information for each of those requests. compiling it, and sending it back. With a solution like a data lake, that person who receives the request, provided they have the right permissions, can simply just go execute the request themselves. All the content is visible to them if they have the right permissions, and they can then compile it and export it right there. Imagine the productivity benefits across federal government. So those are two key elements.
Okay, I believe this is a two-part question. The questioner, he referred to one of your slides where he wrote, quote, data lake provides built-in information protection and security. How is that? And then part B, who owns the data in the data lake?
Okay, great question. So I'll start with part B because I think it's arguably the most important thing. Is that's something you always need to look at when you're employing a data lake. Is if you're doing it internal, okay, who's going to be the owner of this? Is it IT? Is it legal? Is it some compliance officials? Who's going to own it internally? Now, let's say you're leveraging something like Collabspace, which is a vendor-provided solution. In that case, you want to make sure you look at all the agreements and all the fine print and see who owns that content, and make sure that you do. You should own the content. No vendor should own your content or even have access to it. That content is privileged for you and you only, and not for the vendor, and it certainly should never be owned by them. So I always encourage everyone, look at the agreements and make sure you own it. Also look at, should you sever with that vendor, how long do they keep the data before destroying it? Some of them won't put that in their clauses. Some will say they destroy it immediately. Some will give you a little window of time to evaluate and make sure that's the right decision for you. So pay attention to those details of your ownership. So in terms of the other part of the question, when we think about protection from by default or protection from the beginning, the data lake should be, if you're employing it correctly, be based on immutable storage. It shouldn't be something that people go and transact and collaborate on. That's not the purpose of a data lake. The purpose of a data lake is analysis and high volume compute, which requires certain structures of storage and all these sort of things that are not designed for users to go poking in and opening their Word document and making edits. So immutability is a key factor. The data lake must be immutable. Now, immutability gives us our first level of protection. Number one, in the case of any sort of unauthorized or unintended deletion activity or update activity, you always have the prior version as an immutable copy. So you can always go back to whatever version is the one that you need, and ideally restore it or utilize that version as needed. Now, that's kind of protection number one. So we're never going to lose anything, and we're never going to have a malicious or unauthorized altering of any of that content. Number two is any data lake that is storing or centralizing information in this regard will have multiple levels of encryption. And those multiple levels of encryption will go well beyond what the transactional systems typically have. So in most cases, the transactional systems will have some container level encryption on all the content in the container. It's one key, one encryption key, and all the content's encrypted the same way. Or worse yet, it doesn't have that, and it just has a secure connection via web browser, which is bad. We want to make sure the content is encrypted at rest. But a data lake that's properly designed will encrypt the individual items. So it's not going to be just encrypting the container, but the actual items themselves will be encrypted because it can handle the processing power of decrypting them. A transactional system like a file share or Office 365 or something can encrypt in a container level, but can't take on the processing burden of individually encrypting files unless you specifically require that, in which case there are some solutions for that. But that's really the two levels of protection we get right from the get-go: immutability and encryption.
Okay, I think we have time for one last question. So then you're off the hook after this one, Graham. Are government agencies, quote, really ready for artificial intelligence?
Great question. Right now, probably not. As I outlined in my very beginning, I view artificial intelligence as a journey. It's not one that most organizations are ready to just jump right in and say, hey, we're building AI. In fact, you'll see a lot of discussion papers around the ethics of that approach and how it can go disastrously wrong. Instead, I'm an advocate of small building blocks leading up to a chain of events and activities that will eventually take you to the point where you are running something that can be called artificial intelligence. Now, the way that starts, as I outlined, is you got to have your data in a place where it can be computed. Otherwise, AI is meaningless. AI that looks at just an individual document to figure out what that document is lacking all context and knowledge that exists in your corpus of content, and it really won't provide a good result. So what we want to do is we want a building block. We want to lay that foundation that says, start with a data lake so that we have the ability to compute. Then layer on one algorithm, such as maybe entity extraction, analyze all our content, figure out what the entities are, extract them, and relate the content for us. That on its own is not AI. That's machine learning. And that's great and powerful, but it's not making decisions for us yet. We need to layer on more and more of those algorithms over time, because AI is about making decisions on behalf of a human. Instead of the concept of algorithms and machine learning, which is really based on the idea of advanced processing to do something humans can't do, it's not making decisions. It's taking the rules that were given and it goes about its outcome. If we say AI, we're talking about machines making decisions for humans. And no, the government is not ready for that yet. Maybe in certain applications, we can argue that there's probably a potential for that. But by and large, machines making decisions for humans is not the immediacy. But layering this data lake and layering those algorithms is what will start the journey to getting there in the future, when all the questions can be answered and before we flip the switch that turns into killer robots.
Thank you, Graham, and Collabware for supporting today's broadcast. I'd also like to thank the audience for tuning in today. We very much appreciate your continued support. On behalf of Digital Government Institute team, this concludes today's webinar. Have a great day.